Okay, I assume you've read the problem and worked it yourself. Let's go straight into the key. Okay. Find the average rate of change of A of t. Let's straight off our Cintiq card. So we want A of 30 minus A of 0 all over 30 minus 0. And it is a calculator active question, so we end up getting negative 0.197. Indicate units of measure. Now it is a rate. Okay, so we are looking at, let's see, pounds and days. So pounds per day. That will get you 1 point. And if you don't have units, you didn't get the point. So make sure you have those units. Okay. Find the value of A prime of 15. Well, that's just literally using your derivative at a point command. Just typing it in, you end up getting negative 0.164. Using correct units, interpret the meaning. Now make sure you have all those units. Okay. So this is the amount of grass clippings is decreasing. Oh, sorry, my pen is not working. At a rate of 0.164 pounds a day at 15 days. And that's what gets people. A lot of people will have the pounds a day, but they won't put at that moment, at 15 days. And if you don't, that costs you a point. Okay, so that was worth 2 points. One for the answer, one for the interpretation. Okay, part C. Find the time in which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval of 0 to 30. Okay, so the amount of grass clippings is simply A of t. The average amount, well, that's straight off our Cintiq card. That's 1 over b minus a f of x dx from the integral a to b. So in our case, it's 1 over 30 minus 0, 0 to 30, a of t dt. You have a calculator, use your solve command. T is approximately 12.415. And that is days. That was worth 2 points. 1 point for having that average definition and 1 point for finding the answer. Okay, part D. We have a linear approximation at t equals 30 is a better model. Okay, use that to predict when there will be 0.5 pounds of grass in there. Now remember, a linear approximation or a linearization is simply a tangent line. So let's make a tangent line at 30. Okay. So we first need our y value. So I'm going to plug in into the original function, get my y, 0.783. We need a slope, so plug in, use your derivative at a point command. We get negative 0.056. Okay. So y minus our y equals our slope, x minus 30. In this case, I really shouldn't use x because it does say t. It also tells me L of t, so I need to be consistent with what they tell me. So y equals 0.056 t minus 30 plus 0.783. So there's my linearization. Now I need to use it to approximate when will, it says, which there will be 0.5 pounds of grass clippings remaining in the bin. So in this case, I need to set this equal to 0.5 because it's not saying you're plugging in 0.5, you're saying when will there be that much? Use your solve command. We end up getting t is approximately 35.054. Now, even though I don't think that part was very difficult, that was worth 4 points. Okay, 4 points for your linearization, and then another point for knowing to set it equal, and another point for your answer. So, pretty straightforward part D.